Uh, I just flew in this morning, so I might not have as much energy as I normally do, and for that I apologize, but try to keep it lively. I'm Peter Wang. I'm the founder of Anaconda, and I'm currently the CTO, Chief Technology Officer. And today I'm going to take you through kind of the journey we went through at Anaconda, both as a company as well as through this process of growing the data science community, growing the open source community around data science. I have to turn this on. There we go. So my background, actually, my formal background is not in computer science, but actually in physics. And actually, one of my colleagues from undergraduate days is here, and we had a lot of fun back at Cornell. And I was mucking around a lot with computers. I've been coding for a long time, but after I graduated, I went into software development as a career. And I only took 3 CS courses in college. I had a lot of fun with them. They were easier than the physics courses by far. But essentially what happened is after a number of years doing various software development gigs, I ended up doing consulting around the scientific Python stack in kind of the mid to late 2000s at a company called Enthought, and built a lot of kind of early tools there. And then around 2010 timeframe, I realized that the big data movement or revolution, some people are calling it, that the big data wave was going to drive a dramatic need for better data analysis tools than what was around at the time. Python was starting to get organically adopted at a lot of different places, and so I saw there was an opportunity to really push this scientific and numerical Python stuff that we had built. So Travis, my co-founder, and I have been building a lot of these things. We saw an opportunity to take that and really drive it in business. So there it is. So our company's mission from the very beginning has been to build better tools to help organizations harness the power of data science and data analytics, and really put that power in the hands of people who were subject matter experts, who are domain experts. So we make software that the data scientists use, but also very importantly, we provide software that businesses can use to empower those data scientists. All right. So many of you may be familiar with Anaconda primarily as the software distribution. How many of you know Anaconda for that? The open source, right? So great. So this kind of, we call this a architecture diagram, and this architecture diagram shows you kind of the ecosystem of things that happen to make the Anaconda distribution what it is, and it's a very unique piece of software actually, in that it is cross-language, cross-platform, and multiple architecture. So that means you can go and run Jupyter notebooks to write R or Python. You can use Jupyter notebooks on a Mac or on Linux or on Windows. You can use it on ARM or on IBM mainframes or on x86. So it crosses a lot of different matrices. This makes our build farm incredibly complex, but it means that for all of you who use Anaconda, that you can write something and take it from one machine and run it on another machine or another set of machines without worrying too much about that. And one of the key pieces of technology inside Anaconda that makes that possible, all right, is a tool called Conda, which you may have experienced or used as a packaging manager. And what it really is an entire sort of framework for building open source libraries or building code in general, but building in a way that's cross-platform, multi-language potentially, and most importantly, built in a way that is sandboxable, that's sort of self-contained, so it can be installed without having system administrator level privileges. And this is actually one of the reasons why Anaconda is very popular in the Windows world, because many of our business users have Windows machines at work. They want to use so many of the Python libraries, but their machines are locked down. So Anaconda can install into user space, and you can still install a lot of additional stuff. But the fact that we do support multiple languages and we can put these together in these virtual environments, that makes deployment easier. It makes reproducible data science easier. It actually is a much simpler thing to use than Docker and things like that. And it's one of the reasons that our enterprise product is also very popular. So I'm going to stand right here so I don't have to keep doing this, like punching my laptop. So many people know us for our work in open source, but then I always get the question, well, so how do you make money? And people assume that we do consulting or training and things like that, and we do a little bit of it. But primarily, the way we make money is we sell our commercial platform, which is a completely different set of bits than the software that you download and use on your machines as Anaconda distribution. And what the enterprise platform does is it uses underlying technologies like Kubernetes and Docker to allow data scientists to work in a corporate environment that's relatively locked down and still have easy one-click deployments of Jupyter notebooks, of dashboards, of machine learning models and REST APIs, and allows the IT folks to govern and audit all of that. So it's a very it's a very powerful product, and it's used at a lot of really big companies. It's also used at some smaller companies. But when businesses are serious about managing the software supply chain that feeds into their machine learning, that's when they call us up about Anaconda Enterprise. But today's talk is not really going to be about Anaconda Enterprise. It's about the overall journey that we went through. And many of you may already know this, and I apologize if this is a repeat, but I think a lot of people don't know this. And how many of you here are practicing data scientists? Show of hands. Great. How many of you have been practicing data science for more than 5 years? Not that many, right? So the journey takes us back to 7 years ago. My co-founder Travis and I, we had some visions around 2011, 2012 timeframe. And what we realized was that the reason why the scientific Python tools were getting so heavily adopted in the 2000s as a displacement for MATLAB was because scientists wanted to write code. Like, they wanted to express their ideas in code. They didn't want to have to write a spec to give to a Java developer to code poorly. They wanted to write the code themselves so they could then go and fix it when it was broken. And they could also build it quickly and get it out into production, build a thing that they could use to drive some lab instruments or build a model that goes and trades on Wall Street. So Python was getting picked up for these places. We were getting called by everyone from the US Army and the military to the most prestigious hedge funds in New York. And so what we realized across the board was domain experts, subject matter experts, they wanted to manifest their ideas in code, and Python was the weapon of choice for them. And another point that we realized was that there were two things happening right at the turn of this decade, which was that the big data wave was starting to really crescendo and reach its almost peak. And that was going to completely blow up traditional data warehousing. It was going to completely blow up traditional business intelligence tools. People were struggling with Excel's like million row limit. People were struggling with very expensive old tools like from TIBCO and whatnot. And the second of all, cloud computing was starting to hit, and it was mostly being adopted for web development. But we saw the potential for data analytics. The fact that people could go and rent a machine or 100 or 1,000 machines and get like a mini supercomputer on demand to crunch through a lot of vector math. That was going to be a game changer on top of the big data thing. So what we did actually in 2012 was a year after the Jupyter Notebook had been, actually at the time it was called the IPython Notebook, but within the first year of it being released, we created an online notebook service called Wakari that you could just click on you go to wakari.io and you would have a running IPython notebook, and it just worked. How many of you actually used that or heard of it? Anybody here? Oh, okay, a few people. Good, some old timers. The problem is we were way ahead of the market. Nobody could spell IPython. IPython hadn't renamed themselves Jupyter yet. It was way ahead of its time. And it was also, people would use it for free. No one would pay you for it. So we had to kind of move away from that product and figure out something else. But we were onto something in terms of realizing that being able to turn on cloud resources, tie them to interactive computation environments on top of large data sets. Does this sound familiar to anyone, right? This is a very useful thing. And then one other thing we realized was that what we were seeing as we were doing our consulting work using Python, that there were these different silos in business. Most of the business, big corporate environments we went to, and I have a very US-centric view of this, of course, but maybe this kind of resonates with you all over here as well. But we had business analysts who were used to using things like Excel and BI tools like RapidMiner and things like that. We had developers, right, your traditional CS majors who were programmers, Java, .NET, C++, et cetera, et cetera. And in the middle, there was a small tier, but growing. There's a small tier of folks who would be doing things like predictive analytics using SAS or they might be writing some MATLAB code as a quant at a hedge fund. But more and more people in the middle were starting to use Python to do a lot of those things. And the goal here in the middle is not so much to just produce an insight or produce a report, but rather to build out machine infrastructure to build lots of insights and do lots of reports and actually do things with those. So we saw that not only was this middle tier of folks going to be growing, but additionally, Python as a language spanned all three of these things. If you take some Jupyter notebook that an analyst can read and maybe click on a few things and change a few things and have it still run, that same notebook you can give to a C++ or Java programmer, and they would still kind of know what to do with it. Maybe they're going to, complain about white space or something like that, but they could. It's going to be a lot easier for them than trying to understand a pile of R or MATLAB, right? And so we saw that Python as a language that could cross all these different silos was itself, that intrinsically was going to be another unifying, connecting, and very important phenomenon. So we started a company, and this is sort of what it looked like when we first started Anaconda. That's my truck with some used furniture in it. That's my co-founder Travis, and then Brian Vandeven, who's actually the creator. He was the first commit to Conda. He's also the creator of Bokeh. He and I sort of created Bokeh together. This is our first Strata conference, and Travis is pointing to our logo, our first booth there, and our first office. It was a very, well, the company was called Continuum Analytics at the time. It wasn't called Anaconda. And there's a fun story behind that, actually. So we created this company to push the use of Python for data science because we really like Python. And so one of the things we did was we created this thing called PyData. So I registered the domain name. I started the very first PyData workshop, and Google and O'Reilly helped us put it together. And it was at Google's headquarters in Mountain View. It was a small workshop, 60 people, but it was quite a workshop because you had Wes teaching how to do time series and pandas. You had Francesca Alted talking about optimizing NumPy. The late John Hunter talking about advanced matplotlib. Jacob Vanderblas teaching you machine learning with scikit-learn. It was just Fernando teaching IPython and matplotlib. Travis teaching advanced NumPy. This was an amazing, cool event, and it was only like $50 to register for. And it only happened once. But based on the success of this, we started doing a lot more PyData conferences and things like that. And now NumFocus runs PyData events around the world. And at that PyData, though, a very important thing happened, which is Guido stopped by. This is when Guido's still working at Google. And so he came over, and he was talking to us, and this is maybe more of I think this conversation, they're talking about something else, but we actually have it on video, where we approached Guido, the scientific Python community did, and we said, look, packaging is a huge pain in our butt. Like, can we do something about this? Can you convince Python core dev to take packaging of C++ and Fortran code seriously? And Guido was like, you know what? Number one, I don't care much about packaging. That's why it's a sort of second class concern in the language. And second of all, maybe your use cases are so exotic, you should build something that works for you all. And so we did. And so we built Anaconda. Wait, something is not going right here. Right, because what we needed to do was we realized if we wanted to ship Python for big data, if we wanted to ship all these advanced tools like just-in-time compilers and all these other kinds of crazy things, web frameworks for visualization, we were going to have an even bigger packaging problem than we already had just trying to ship NumPy and SciPy matplotlib. So we started the company to try to build all these great capabilities in the Python space. But to do any of that stuff, I'm going to stand behind the podium here and do it this way. In order to do any of these things, we had to be able to get the software into people's hands. And so we wrote a package manager called Conda. And we built, I remember the moment I turned to Travis at the meetup, or at that conference, and I said, we need to create our own distribution of Python, because this is going to be nuts to try to get people how to, to install the stuff. And because it's Python for big data, we should call it Anaconda. And that was the moment of inception, really, was in March 2012. And so by September, we created the first version of the distribution. We added Windows support, which has been useful for some people, I guess. And we had all sorts of other fun things that we did. And starting from that point, you can see the inflection that really changed. That was an inflection point, and it bent the adoption curve of Python. Because prior to that point, even though, let's see, matplotlib was probably 7 or 8 years old, and SciPy was 12 years old, people were all the time coming up onto mailing lists and complaining, I can't install this, I can't install this, this compiler is blowing up, this is not working. Once we created Anaconda and made it easy for everyone to install all this stuff, a lot of that stuff just went away. So I think we really helped, drive the adoption of Python. And to show you what that looks like now, this is our weekly unique engagements on our Anaconda repository. So it's over 1 million unique IP addresses every week. On a monthly basis, it's about 2.5 to 3.5 million. And to give you some sense of scale, how many of you have heard of Tableau? Yes, everyone, right? RapidMiner, maybe some people, right? Their data mining tool. The entire Tableau user base is something on the order of 500,000 users. The entire RapidMiner user base is something on the order of 440,000 people. Those are numbers from those companies themselves. So we, in our last trailing 12 months, unique for Anaconda, our repository, our download sites, and everything else is 16 million uniques. So this is absolutely a movement that you all are part of. It's growing, and open source is at the heart of that. Now, packaging, I talk a lot about packaging, but packaging was not the only problem we had back in 2012, right? Number one, people complained about Python being very slow. And in fact, some people were looking at Julia with great envy. In fact, the J in Jupyter stands for Julia, right? Julia Python R, Jupyter. So we didn't want people to have Julia envy. So we use LLVM and a couple other hacks to create a just-in-time compiler called Numba, which is now becoming quite popular as a way of very easily accelerating your Python code without having to step into C++ or anything like that. Also, people were doing a lot of R versus Python stuff back then, and there wasn't a way to do Shiny for Python. People said, I would walk away from R except ggplot and Shiny. So we created a library that would suffice that particular need. And then also, there was this question of scale out, and there was multiprocessing, and there was a lot of other things that you could do with MapReduce. But it was clear that the world was going nuts over Hadoop and MapReduce, and we needed something in the Python space. And it took us a few years to get there, but we created a framework called Dask, which is a much nicer idiomatic way of doing scale up and scale out in Python. And these projects continue. We created those projects, and they continue to add features and get more stable and get wider adoption. So Numba, now you have very nice GDB breakpoints from inside your Python functions. You can build dictionaries, basically write Python code with dictionaries, and that all gets compiled to extremely fast, tight machine code. And of course, Numba has always been a really excellent way to easily target your code to GPUs as well as CPUs. Dask has been gaining a lot of great interop with Yarn and Kubernetes. Also, we're adding support for GPUs so we can load balance across them. And more libraries in the Python space, like scikit-learn and pandas, are keeping Dask in mind as a way of doing scale-out and parallelism. And then on this side, we've created sort of next-gen set of things to do dashboarding in Python. So for instance, Panel can use any number of Viz libraries and give you interactive widgets and very nice dashboards, either standalone or within Jupyter Notebooks. And we've also added large data visualization support. And we've just been through our work with some of the US Army research funds and NASA and whatnot. We've actually built some really, oh, wow. Can everyone hear me okay back there? Is this okay? In the back, can you hear me? Okay. We've been building some really nice large data set visualization capabilities. So I don't know how many of you have heard of Data Shader, but we can actually render billions and billions of points in an interactive Jupyter Notebook on a laptop. And these are these are some of the plots that we've done with those capabilities. And we're still creating new ones. So just last year we started a new project called Intake, which is a lightweight Pythonic data catalog. It's not as heavyweight as something like Tamer. It's certainly not meant to be like Immuta or Dremio, but it's something very simple for you to be able to run a little server that front ends a bunch of data and be able to connect to that server remotely and drive some computation on it. So simple, lightweight Pythonic, and it's starting to get some nice grassroots adoption. I'd encourage everyone here to take a look at it if you have a chance. But in doing all this stuff, and this seems like a fairly linear sort of path, we learned quite a few lessons, right? The growth of the company and the stuff that we did from 2012 to now was during a time of great churn and great innovation in the data science and machine learning space. We saw big data come and go. Then we saw the rise of data science. And even as people were questioning the validity of the term data science, we had machine learning rising. Even as people were Googling what machine learning meant, we had now AI. So I don't even know what comes next, like quantum blockchains, I guess. But the last 5, 7 years have been just layers upon layers of stuff. And I kind of break it down like this. So the first 3 years of the company, we really spent in kind of this open source consulting, bootstrap sort of mode. And the industry was sort of peaking on big data, data science was emerging, and our biggest competitors was just our own, potential, like crashing into the ground and making a big crater. We could, you know, we could stop. We'd failed to push Python for data science. People could just go and do other things. And also, we were competing a lot with other things like Hadoop and Spark and R. Python was not an established force. Many people, to my face, would question, my sanity in pushing something weird like Python for the stuff. By the time 2015 or 16 rolled around, those in the know were pretty much, they know that question was settled. But we ourselves as a company were transforming into becoming a product-based company. So we took a fairly robust Series A, and then we had to rejigger from our services and consulting training model into trying to orient the product engineering group towards building commercial enterprise-grade product. And now we've brought in sort of a seasoned veteran executive as CEO. We've hired in a fairly veteran management team, and together we're growing the company and trying to figure out, in the space where there's so much noise, how can we build well-engineered products that do what our customers need, but still manage to kind of keep on top of the hype cycle and also stay true to the covenants that we've made with our open source community. And through all of this, I mean, these are some business challenges, there's technical and landscape and marketing challenges, but throughout all of this, the biggest challenge has always been about people, whether it was about the community at large and the data science personas we were trying to service, or whether it was about individual library authors and innovators in the community, whether it was about our own internal employee culture. Throughout the entire journey, the hardest thing has always been about people. Even though we're a very deeply technical company, we had plenty of technical challenges and business challenges. It was always about people. And one of my favorite quotes is from not from The Little Prince, but from the author of The Little Prince, in a different book, actually. And he says there's but one veritable problem, and that is the problem of human relations. Throughout the entire time that I've been building the business, throughout the entire time I've been trying to build the PyData community, this just constantly rings true for me. And it's kind of a touchy-feely kind of a point. I can imagine some people in the audience are just like, well, okay, whatever. But I mean, that's nice. But I've got like a lot of technical challenges, right? There's a ton of stuff that I'm being asked about. There's a ton of stuff going on. Saying that we need to be nice to each other doesn't help any of these things. And in fact, actually, I think the challenge that we face really in this space, right? We're not just building random web services. We're actually building machine learning systems. We're doing a lot of deep data-driven analysis, and we have to communicate these to sometimes less than savvy audiences. And so our challenges, even though they may appear to be technical, when we ask those engineering questions, like what is the right answer? What is in the right problem? How, what is the right thing to do? What technology is good? Is it churn? Is it progress? How do I actually, those of you who really want to do good work, you're probably asking yourself, how do I actually engineer from principle? As opposed to just throwing something at a wall until it sticks. And there's this great quote, sort of paraphrasing Isaac Newton. It says, scientists progress by standing on each other's shoulders, and computer scientists progress by standing on each other's toes. There's a whole lot of toe stomping going on really in the industry. Although I guess if we go to quantum toes, then we'll just overlap. But there'll be less squealing. But really, our industry, the computing industry in general, lives in what I call the long shadow of the 70s. So many of the things that we still use were invented in the 70s. Of course, we still use some of the things invented since then, but not that much, actually. If you're not careful, sometimes you'll just download binaries on the web that are machine learning libraries or open source libraries, and they're compiled with the Pentium target, which dates from the 90s. They're compiled with a very baseline instruction set architecture, not optimized for any modern chip. A lot of you probably are in shops that use a ton of Java. Java is very old, very, very old language at this point. And the things that are really popular still, like Excel, it's basically the same thing as VisiCalc, right? And any of you who type dir or mkdir into a Windows DOS prompt, you're using essentially a clone of CPM from 1974. And certainly many of us use Unix, right? And these Linux primitives, the Unix model, all of that stuff dates from the early 70s. Uh, I don't know how many of you drive a 1970s car, but you use 1970s computer technology for the most part. And so, now on the one hand, this is really great. It means that we invented some really solid abstractions. On the other hand, it might mean we're really stuck. So in the face of this, how do we distinguish progress from churn? One thing I can suggest, I've been programming for quite some time, but throughout my entire tenure as a developer, I found very, very few books that I could consistently and constantly recommend. And the Pragmatic Programmer is a book that I recommend without reservation all the time, always. If I could recommend one programming book to my children, it would be this one. And in it, it lays out some of the basic design principles for how to build robust software systems. Now, for data scientists, there's an additional set of concerns. But as the artifacts that we build in the data science community become more and more like software and less like a bunch of random data scripts, then we need to consider these things, keep these things in mind. It's just absolutely a fantastic book. But another book that augments this one really well is called The Clean Coder. And uh, the 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 clean coder doesn't talk so much about software design and programming technique, but rather it talks quite a bit about the personal development that you must undergo, your who you are as a person, and the way you must look at your work if you want to be a professional developer. And I think this sort of carries over to data science in a way as well. And some of these things, again, these feel like very touchy-feely kinds of things, but these are absolutely critical if you actually want to build good teams that can go and actually answer those questions of what is progress versus what is churn. One of these really important things at the end of it, the end of the day, it's about continuous learning and it's about humility. And in fact, the things that I see, whether it was the Python community and the PyData community, whether it's within my company, the things that held us back the most was when the team failed to have trust with each other, when people let their egos get in the way. The smartest developers, I mean, so the people who build things like Conda, the people who build solving extremely hard build problems, they could sometimes be incredibly stubborn and would resist talking to other people who are building other amazing things. And it was very frustrating for me as a manager, as a as a founder, to have a founding, put the team of really smart people together and have them just be at dunderheads with each other when they're both obviously very smart people, both obviously mission aligned, but they not in those cases when they had that kind of conflict, neither party really reached inside and figured out how to be vulnerable, how to build trust with the other party, how to actually express humility in a way that could allow the team together to progress. So the two things that I found throughout this process, the two things that you really need to have in order to have vulnerability, one is you must have self-confidence, not arrogance, but actual self-confidence. The confidence to say, I know this and I don't know that. And then, of course, the group. Now, you can only say, I don't know that, if in a group, you're not going to get kicked out of the group for saying that, right? For showing weakness. And so, one of the things that is incredibly important is as a manager, as a team lead, is to facilitate creating that kind of supportive structure where people can openly talk about what they did right, what they did wrong, what they know, what they don't know. And once you have that, then you can actually progress and move forward. So one of the core company values we have at Anaconda is we hire for people that have both ability and humility. Now, humility doesn't mean false modesty. Humility simply means recognizing that you are probably not the smartest person in the room on everything. You are probably pretty smart about a lot of things, and your job, therefore, is to figure out what other people are smart about and what other people are not smart about, so you all can be smarter together. And that's what that humility is. But it takes a group, it takes a village to build that culture of humility. And we have had a few painful, exceptionally painful lessons when people fail to have humility, and it cost us a year or more in terms of a product release cycle. It cost us, many good people leaving because leaders, people in the leadership positions didn't have humility. This is a very painful and difficult thing to talk about because a lot of good people put their heart and soul into this stuff. But at the end of the day, the failings were very simple. I put them up on one slide. And so I know when I was talking with some of the organizers here about what to talk about here at the Fifth Elephant and here in India in particular, a concept that was brought up was that really, certainly in Indian culture, there's a tendency to want to be very credentialed. There's a tendency to really want to put your persona and a facade, project a very strong um, and a very very strong facade. And the danger and the cost of that in settings such as a company or a technical team, the cost of that is that everyone is then blind to your systemic risks. For data teams in particular, for data scientists in particular, that is exceptionally dangerous because you all represent the brain of your organizations. And we all know, we've all played with data, you can find whatever you want in data. You can tell whatever story you want to. And if it's all about posturing, it's all about making yourself proving that you're smarter than the other person, um, you're going to end up really hurting your organization. So, on that note, so what comes next? So if we have done all these great things to kind of get data science in Python to where it is now, what do I see as what's coming up next? One of the things that I think is really, really important to drive home is just how much hardware innovation will be coming down the pike. How many of you use GPUs in your work on a kind of regular basis? Anyone? Not that many people. How many of you are interested in using GPUs in your work? Okay, a few more people. Um, how many of you would like to make tons more money doing deep learning? All right, there you go. You're going to start using GPUs then, right? Or TPUs or something like that. How many of you are interested in IoT? So now you're going to start running your machine learning models in things that are not x86 probably. So this is just a quote from ARM, but really I was shocked. It was the last year I started taking stock of how many new kinds of chip architectures were coming out that we would have to support, because again we have to build stuff to run on all these different platforms and architectures. So for me, it's a bit of like a sobering thought as well. But as of 2017, these were the chips that have been announced, the kind of architectures we sort of figured we'd have to support. People were talking about deep learning. We knew we'd have to throw GPU plus CPU kind of workloads together. But by the end of 2018, the number of chips that have been announced was way more. And there's more, this list just keeps growing. Um, and so what this means is that, I put this up here just to sort of stress that many of the people in the IT space who have been doing software and hardware and infrastructure and system architecture. Maybe you've been doing this for a couple of decades. You know what it's about. Throw a Linux kernel here, you put a network switch over there, you kind of throw some data things around. All of that is actually going to change quite dramatically. And the innovation space that is going to be that we sit at the intersection of, that innovation space is going to grow by leaps and bounds in the coming years. Um, and there will be a tendency to say, well, gosh, that's a lot to keep track of. I mean, look at all these chips. Do I have to buy all of these? Do I have to go qualify my algorithms, all of these things? No one's got time for all that. So there's going to be this um, temptation to outsource the problem, right? Oh, here is this vendor. They sell best in class, yada yada pipeline. We should buy that pipeline. And the thing I would stress to all of you as decision makers, influencers, practitioners, the thing I would recommend to all of you is to be very, very clear with your management, with your budget authorities, that you cannot outsource innovation in this space. If someone is selling you a predict button, they're your competitor. They're going to take your data and they're going to outcompete you, right? And there's no big red solve button. There's only a big red pwn me sort of button. And you generally don't want to pay for that. The thing that I think what we really have to do as an industry, again, going back to that concept of engineering on principle, I think we need to move past the 1970s and 80s view of software, infrastructure, networking, hardware. We need to actually move to viewing the entirety of a computational system as an inference engine and looking at characterizing the qualities of that system, managing it, auditing it, engineering it for debuggability and manageability. That's a really, really huge cognitive leap for a lot of businesses because they're so set in their ways. Now, I know many people here work at startups, younger companies that have a lot more flexibility, but you're also under the gun to deliver under much tighter timelines. Those of you who work at bigger companies, start thinking about this. Start thinking about how can we build cross-functional, sort of I don't want to say interdisciplinary, but across the different silos of management. How can we actually start thinking about this overall thing as one unified, holistic thing? Right now, people talk a lot about model management, And the ugly truth is models consist of two things: data plus software. Well, most people are not really governing their software very well because they throw everything in a Docker file and just pray that doesn't get hosed. And then they're not governing their data very well because the data governance, either it's good because it sits in a giant, slow enterprise data warehouse, or it's hardly governed, hardly really, managed because it's streaming through, or you have a very ad hoc process with a bunch of S3 tables. So there's a whole discipline that has to grow up around managing both of these in concert, holistically. Um, and I think one of the maybe one of the takeaways here is the reason, what's the difference between a machine learning model or a data science model? How is that different than just regular software development? This is a question I get asked quite a bit when I go and talk at in-house at places. And the way I characterize it is that traditional software development really puts data as an afterthought. Data is the input to the system, and no matter what values you get, the correctness of the function is orthogonal to the values. Machine learning models are not that. Right? Machine learning, data science kinds of applications, the correctness of the system is highly dependent on the values that go into it. And that is a complete paradigm shift from how any of these things get managed in IT today. And so two things I think that are going to happen in the next several years. We're going to have to redefine the entire stack of governance, management, and auditability around these new computing systems. The software development lifecycle, the application lifecycle management sort of practices are going to have to evolve. And lastly, I think we're going to have to re-democratize computing. Basically, building the kinds of things we're building, the natural endpoint of evolution for things like Jupyter notebooks, I think, is actually serverless computing. A new version, perhaps, of the Python interpreter that doesn't require being grounded in a Linux kernel running somewhere on somebody's cloud. And thinking about how we can go beyond just Python users writing a notebook, but all of the Excel users being able to write simple expressions inside code cells and actually going to a much broader use base for the Python language. That actually is an incredibly powerful concept. And it sort of completes the full vision of what Travis and I were trying to do when we first started this whole thing, about giving the people who understand the domain, giving the people who know how to ask the right questions, giving them the power to answer those questions. Um, and of course, all of this will require infrastructure on demand. So if you don't have that, then you can't even play this kind of game. But I think these two things: number one, this wholesale redefinition of the entire stack of management, and then two, democratization of computing around a Python-centric, a roughly Python-centric, and certainly very data-oriented set of workflows. These are the two big trends that are going to happen over the next 5 to 10 years, without question. Thank you very much.
Thank you, Peter. Thank you, Peter. Okay, thank you, Peter. We have a joint Q&A with you and Chris after